Hello, my name is Jacob Edison, and this is my first major-ish endeavor in Python besides the practice exercises that are given in my computer science course. So, this is Programming Projects for Advanced Beginners, and number 2, Game of is by Robert Heaton. So obviously, robertheaton.com is his website. I will link to this article in particular in the description, in case of anyone wanting to do the same as me and follow along. Obviously, I suppose an advanced beginner is the way you could say it. I know what I'm doing with Python, but I've never really structured a huge project before. So I will maybe be struggling a little bit with this, but that's part of the learning. I'll get the hang of this better and better as the time goes along. I have my goals set up down in the bottom in a little paint window that I'm going to work with. Well, however, let's just hop right into the Game of Life by John Conway. It's not really a game, as Heaton says here, but there is a 2D grid with each square having a cell either alive or dead. And going through the rounds, each cell will look at the neighbors around it. And so we will load this up here. Is that visible? Good. This. Okay. So looking at the grid down there, we will interpret blue as a live cell. So if just those two cells are alive, rest are dead, then just one of these live, then dead. If 0 of them is alive, it's also dead. However, once we get to 2 cells alive, the cell will stay alive. Same with 3. However, then you reach 4, which is overpopulation according to the rules of the game. And so this cell dies. And unfortunately, the only way of getting a new cell is by having exactly 3. So now I say unfortunately, but obviously there's quite a balance in this, and it makes some really nice patterns. But any more than 3, you're looking at a live cell dying. Any less than 2, you're looking at an alive cell dying. 2 or 3, just right. So with that out of the way, now we kind of understand how the game works. There's some goals set up from running this game. A little couple examples here with Pulsar and Gosper Glider Gun and some more complicated machines. And so how this is going to be dealt with is big projects are a lot easier to deal with in smaller testable chunks, in the same way that I guess you could say you don't build Rome in a day. You work on it one piece at a time. And as he describes it, you wouldn't try to build every part of the house at once. You have to break it down and plan it out. Build it all one piece at a time. Now, we are going to look at the milestones here, and it's going to be building a data structure to store the board state, pretty printing the board to the terminal so that it looks not 1s and 0s the way we want it handled, but more squares. And then given a board state, calculate the next one, and run the game forever. And so we are going to start with step 1, hopefully move on to these extensions later on, but start with step 1 and not overwhelm ourselves too much. And so step 1 going to be running some Python. And that sounds simple enough. One can only assume there's a quick, you got to install the Python extension if I remember correctly. So let's go ahead. Add Python. And now that'll allow us to create some Python scripts. Python module. Back, file, create Python. All this. Select that folder. I do trust the authors. So next, create a Python file. So that is what's gonna take over the screen. Untitled 1, which we will immediately save and rename as board states. And so we're gonna want to give the board. We're gonna want to create the board, which you're gonna want to do using random state, which will get your board's width and your board's height, and then return a board in which every cell is either alive or dead, which will be a 1 or a 0. So what we're going to start that with is gonna be you're gonna want to get an input. So define random underscore state with width and height. And then your board's height's gonna be each subgroup. So you would say row in length height. I guess is how you'd go about this. I'm gonna work through this on. Want to first, I guess, initialize board underscore state blank empty list for column in length width. Suppose I should do range length. We're gonna need to import randint. And so to deal with this, we're gonna want to append another list. Board dot append. Rand int 0, 1. And then head return 8. Saving this. Putting this in the table. What did I... Wondering what I did. Definitely is random state. It definitely... Sorry, it's not length. Another mistake I made there, where I'm used to given something and having to, rather than simply try that now. So yes, we are now doing a 2x2. Let's try 3x2. So with 3, height 2. I'm a little concerned with the amount of ones. It does feel like just a bad stretch there. Anyway, that will now optimize your state, which is as he was suggested here. Now, this wants to start with a simpler function called dead state, which I guess we jumped the shark a bit there. I'll be careful with that, but let's do dead underscore state with height. And then board state will be the function variable again. And I think the only difference is it will append 0 every time. Now let's try this. We're going to want to print dead under state. Just do 5 and 5. Start. Run all this. Yes, okay, perfect. That is what suggested. Print dead state blank, and it will output that, as I was hoping. And now dead state does pretty much do what I was expecting. So for random state, you actually want to use dead state. Okay, that's interesting. So for state, is he gonna be do dead state width and height? For we're gonna do the rows in range length. I mean, you can just do range height still. Row and range height, and then column width. It should be board state board under column equal to 0, 1. Get out of this. Now let's try this new way of going about it. That go. And there we have it. As you see down here, we have a randomized grid. And so this is, in fact, what he does. Now, there's a little bit of a difference between how he goes about the random. He's going to generate his own random number. However, I do like how this operates. Just gives you the number you want to put out there. I don't know if there's maybe a bit of bias in how the randomness is. I don't know if there's something maybe I'm not 100% sure of there. However, it doesn't look very good. So what we've already done is build a data structure given the board to store the board state. And so we can go ahead with our brush, check this off. Now we are on 2, which is pretty print terminal. Now we're going to go about that. We're going to create a render function. So let's define. Now I wonder if I should maybe make file in here. Or board on render. Huh. Probably should have created that in as a Python file. Wasn't aware that that would be an issue. Underscore py. There we go. That's all there is to that. And so I'm gonna need to define render state. And so for this to all run smoothly, I do believe we're gonna have to all. And so, now that we have this render set up, we're gonna want to actually get it all set up. Take one argument, the board, and then format the board state and print it. So, obviously, probably gonna be looking at a board of, how do we want to represent this board? Using hashtags, I think I prefer asterisks. So let's just look at this from a so we're gonna need number of columns plus 2 for rows, for bars on the top. This will print all of it. Rendered blank string. And so rendered, actually not going to start it off as, we're going to start it off as is the dashes for the upper board times length word 0. Is that going to give you the number of? It is, right? Because length is the number of rows. We're going to want to print that times the number, the length of plus 2. And then plus, that's fine. 4 red. That is all from 4 row in board state. Rendered on believe here it's going to be just the backslash new line. And then for column row in length board state, like that, so we can index specifically. we don't need. We do for this one. Sorry. So fix that. For column and boards, this will be accessing this column. If equal to integers, right? Double, yeah. 1, 4. Board is have asterisk added to it. Else. Case added. Which should go as if. So what it just should do is add a new line for every row, a column in that row. It'll go through each row, and depending on which one. The very end. We need to. And then it should print we don't need to right now. Copy. Okay, so obviously we've. Question is, what was it? That's gonna be the part that I'm struggling with. Let's just get rid of all of this first. Oh, it reset the board at the very end. That was part of the issue. Wonder how much. Frigged it up. One thing. That should be good. There we go. Now we're talking, are we? We don't have the bars on the outside. I completely forgot about that. Let's look at the final row. 1, 1, 0, 1. Perfect. That does render the way we wanted it to. And so now we just need to add a thing on each side. We're gonna add we can add this bar like that. Bar. Already gone through all the columns. We'll just add rendered board. That'll get the job done. Yes, sir. Now we have it printed the way we want it to, as you'll see down on the bottom bar. Pretty printing it. So that'll mark that one as done. Just double check this. Let's try to render actually. That's some comments. Loops through. From then we're gonna actually just do dead state to state with 2030. We're gonna render both of them. Equal to. And how? 1, 2. I'm guessing this is the right number. Looks close. Definitely looks like a similar board to what I would expect. So I guess that is good so far. And so Python cache. That's we move on to calculating the state of the board. In order to do that, created the initial board. We're going to need to write a next board state. And now this we're going to make a next board state function. I will make another new file for this, board underscore .py, and we're going to define next underscore board. All from board states. And so given a board state, we're going to need to calculate the next board state. We're going to have a board of length and width, so of a number of rows and a number of columns. So envisioning this, something like, when we go back up here, we're gonna want to check. Let's just say we're looking at this column. Oh. Whiten out the entire. As white as we can. For me. Say we're looking at this board, this one up here that I just made red. We're gonna want to check this, this, and this. It's actually probably better to look at the middle because that is where we will see the extent. We're gonna look at okay, so treating this hypothetically as coordinate, let's say 0, 0. This would then be one above, so this would be... If we're gonna have to reverse the coordinate system, so we're gonna have to reverse the coordinate system. This up here will be... Do we only have to reverse the we only have to reverse the coordinates vertically, right? Further to the right is still more. It's just further down is more in the case of this list. Then this would be -1, -1. This would be 0, -1. -1. Y is 1. The Y value is going to be 1 less. This would be -1, 0. Would be 1, 0. This is 1, 1. This is 0, 1. It'll be -1. And so, for the sake of checking each square, we're going to have to check every square around here relative. This is the relative to a square's coordinates, what we'll have to put in order to get this next square. And so, as far as that goes, we can sum up all of this and get a value. Sum up what's in, each of these squares around it. So 1, -1, and all so on and so forth. Until we get that. So you won't be able to go above. You'll only be able to check the ones above if it's not the top row, below if it's not the bottom, and so on and so forth as well. So that's I think the most complicated part of figuring this much out, I believe. So, we're gonna need to get 4. We're getting Y coordinate first, right? We're gonna have our Y coordinate, our X coordinate. For X coord, aim for I mean, you could just do 0 in this case because it'll always be. Why, that does make sense, right? are gonna get that first, which would all be 1. Here's the tricky part. We're gonna start like that. A lot. Start off as 0. Now I'm gonna take a quick bathroom break, and we'll get right back to this as soon as I'm back. Okay, we're back. So, what I am going to struggle with perhaps a little bit here. This is what they said, dealing with cells on the edges. So I'm going to try not to read them, but there might be a struggle here. We're going to keep count of our live neighbors, which is 0 here at the very start before you iterate. And then let's start with top left. If, which will be -1 and -1. So if y card does not equal 0, chord 0. You're gonna add. You're gonna add to it the value of gonna be a lot of ifs here. So then we're gonna move on. We can move on to the next 2 corners. 0, -1. Then if y chord does not equal 0, gonna keep the x chord the same. If then we're going to want to avoid the other edge case as we get to the top right cell here. Let's go to my image. As we get to +1 and -1, we're going to have to deal with both. So if y chord doesn't equal 0, chord doesn't equal length chord at y chord. Length of that would be plus, so we're gonna have to -1. I think that's how that works. And then you can, I'm actually just gonna copy this. So we're not going to have to worry about the y chord. Then we're going to have to look at 0 -1, right? So that's if x chord's not 0. Then you'll be able to go to the left. If x chord's 1, you can check x chord 0. And then So we do not check this one. Yet, at least. And then if X chord not equal length of the, so let's say there's 10 elements in the row, then 9 would be the last, so yes. It is -1. And then we're gonna go below. Row. Now we're gonna be looking at +1. Does that make sense? Y coordinate, not place it in the lowest row. So if it's, in this case, our lowest row is 1. So if it's not equal to, because it's rows, it's not equal to those 2 rows, the second row, which is actually row 1, not equal to 1. Not. X chord is also equal. We're gonna have to +1 -1, right? Yeah. Y chord. +1. What this is gonna do, by checking the number of live neighbors, is going to tell us what to do based on the number of neighbors and the value of our cell. That's why we haven't checked our cell yet. So then if Y chord +1 +1. Fine. Okay. That should get you the number of live neighbors. And then given the number of live neighbors, if a live neighbor less than 2 is less than, and just by default set this to 0. So board state Y chord X chord just becomes 0. Else, if the number of alive neighbors is equal to 2, if board state is already 0, or if it's 1, then it stays that way. Okay, so 2 neighbors, there's no change, no matter what. I don't even think we need a case for 2. It's equal to 3. No matter what, this state will become. Okay, so if it's 0 or 1, then it's dead no matter what. It's 2 or 3, it does not change. And then if it's 3, it becomes alive no matter what. that works. Which means now we just need... or alive neighbors is greater than 3. So in the case that it's 0 or 1, sorry, 0 or 1 or greater than 3, the state will always, the cell will always be dead. If it's 3, the state will always be alive, and if it's 2, then it will depend on what the cell currently is. Based on the state of the cell and number of alive neighbors. That should work how it should. So I do believe... So this is going to try to make a life... So they have set up a life unit test here. I'm just going through to make sure. So they have a way of testing that. So let's get a check on this. Let's... Okay, so from... Oh, is it gonna make me put... Gonna make me put brackets around all of these. Get rid of all the red bar. That's also good. We have no more issues in this code. Now the question is, what is this looking? I am curious because I'm not exactly sure what this is going to be testing. I have a feeling it might. Failed number 2. Okay. Question is, why did it fail test? Does it have something to do? Okay, so it does fail number 2, but why? That's what we're wondering. And how do we deal with that? So this cell would have no neighbors above because the y coordinate is... it shouldn't even Shouldn't check any of its neighbors above, but it should check its neighbors. Maybe it has something to do with repassing it. So maybe it's failing to check the bottom. Trying to figure out which one it would be. It's the same Y chord. It should check right. Unless it has something to do with this. This board state sets to 1. The number of is 3. And because we have 3 alive neighbors, it should. Pause this for a little bit and look over it all. I might have it. We have the double equals right here. Obviously. Do what we want it to do. Huh. Wondering why it would. Now it sets this 1. And why it would pass 1. It's interesting. Because that really did seem like it was all that. Why is this still failing? Should check the cell to the right, which it does. Board state, Y coordinate. Same. One Y coordinate for in the. That's something obvious. Does this not work like that? Brackets. Out. We'll try this for all of this and see the difference because I'm not 100% on my old Python. That hasn't. Like, lost, little lost here. Now, I'm curious. Set this to a 1. And it definitely should. You have to print alive neighbors. And now getting it to print, it should. That's interesting. Is it only doing it once per... I'm wondering. Oh, dang. Yeah, that was what it was. So it was only checking it once per row. That should be good now, but I do think... Initialize state we're gonna do for test 1 should be all alive cell. And then I think, let me trace this out on paper really quickly. It has all alive neighbors. Say has 1. It has more than 3, so it'll be 0. It'll be 1. 0. So it should actually just be 1s in the corners. I could also be tracing that wrong. There's 0. Now that one should definitely still flip, shouldn't it? It has... yeah, 5 neighbors in there. Okay, that is the other thing I... Maybe I'm tracing that wrong. Maybe just like put it into a... No, I fully want like one at a time. I'm looking at it here and I'm trying to figure out all 1s. Number of neighbors greater. And what cells flipped that it should? Looking at this here, that has 5 neighbors it should be checking. I'm gonna need it to print out the number of neighbors. There's the issue. It's like, no. We need it to count the number of neighbors. So yes, it should count 3 for the first one. Oh, as soon as it flips. As soon as it flips, it, yeah. I see it now. As soon as it flips, it, Right. Is that supposed to happen though? How does the game of life work? All cells are updated simultaneously. Yeah. Now I'm gonna have to make a copy of the board. Let me just run a double check here. Well, I'm not okay, because now it's in now it's not in Python anymore. I'll just do this by making a new file, test.x is equal to. I just want to make sure that it doesn't. I feel like I've had issues with this before. Maybe I'm thinking about some. Probably. Okay. So yeah. Board to next underscore state is word the turn copy that definitely shouldn't be updated. Let's test now. Still failing? It shouldn't? Because it shouldn't, because 1-1 should have it. Now I'm expecting it to. I'm just trying to figure out why it's not why it's still updating. Again, this is what I feared. Now is it the fact that it's in the function that's not copying it properly? I think it's the fact it's in a function. Would this work? No. I am a little stumped because obviously 1-1 should be returning 8. But because it updates 2 things before it gets there, even though it really shouldn't, because it's only should be changing next state, it also seems to change. And that's a little frustrating, because obviously when I tested it just then, is it the fact that it's at a function? Because that seems like the only... And if that is the issue, I don't really know what I do about that, other than like creating a new list in a much more frustrating way. I have an idea. List of... No, because it does have to be a copy, that's the thing. It has to keep all the values based on what I'm doing. Because it won't change. Okay, this is the main technical difficulty I'm at. I know what the issue is. I don't know what. What if I do this? Is this best for anything? That doesn't fix it at all, does it? No. And the issue is still that it updates everything. Now that's... I just don't understand that. That's all I'm missing now, is figuring out how to update this list without it being a pain in the ass like that. It'll always change the, their cells. We could rebuild the list, but that's also like cheese. Why are we doing that? Okay. What if we set next state as a blank list? Next state dot list. It's 2, it stays the same. Let's just double check that again. Yeah. If it's dead, it dies. It has less. How much does this break in? All it fully does. That's me just blowing the syntax. Oh, Lord. There. Boom. And as we see, it does in fact have the number of neighbors we expected it to have in every. And we're getting that print there because I want to count the number of neighbors. That's added down here. Print the coordinate and the number of alive neighbors. Because that'll tell us if the counting is working properly. And that was what was wrong earlier, was that the counting, because the values were flipping before it would return the list, then, yeah. This, like this. Let's get rid of all. Well, like that, but that's not exactly what we're trying to do. So instead, get this back open. Close some of the programs that I just accidentally clicked on when I got confused. Let's copy this again into this paint. And let's crop it down. Oh. Dude. Okay. Let's get this back in then. Anyway, looking at just these squares in the red area, let's count the number of squares in each. just to double check what it outputted for me. And that's going to be the last major test. We're going to look. Neighbor of the... They're all... every 5, so that's 3. Neighbor, 1, 2, 3, 4, 5. 3, 5, 3. 5, 8, 5, 3, 5, 3. So 3, 5, 3, 5, 8, 5, 3, 5, 3. 3, 5, 3, 5, 8, 5, 3, 5, 3. Bang. And we passed, so that's big. Now it's back to here. Now that all the testing's been done. Let's look at some of the other hints. Store the new state. This is what we struggled with. And this is how we iterated along the board. Dealing with cells in the edges, we added if statement. Now we just need to create eternal life. Okay, we know how to build a life board. We know how to run a single round, and now that all that remains is to make it run forever. And so we can delete this little test.python here. And now first we want to initialize our starting state. So we're going to make a new file, and we're going to name it game of life.py. And we're going to do date x equal to integer input Then for our start state, we're gonna not gonna need to go to board states. We're gonna need to take random on our state. Okay, so now we have our starting state. We're gonna make an infinite loop. While true is just an infinite loop, right? Yeah. While true. Oops. We're actually just gonna call this board under. Start under. This is very inconsistent with the way we've been typing things recently. Render board state, right? That's all we're gonna want it to do. That piece anymore. Render board state. Is that all it takes? We're gonna do right, we have the print statements in there still. Get rid of those. Those can't. Fuck it up. Stopped it. Huh. Well then, we've reached the the finish line, and it will not let me kill term. I'm begging you. I don't want to do this anymore. How do I... Like... I don't even... This is just a case of I don't know how to kill it in this. Because in spite of my best efforts, kill terminals. There we go. There we go. Oh, well, did we just get an infinitely looping starting one by sheer bad luck? That's funny. Wow, what? Did we mess something up in the last second? Like, why is it... What? Are we just getting, like, ridiculously unlucky? That's completely empty, as far as I can tell. Is that because both of them only have one name? So do we need to do a bigger board for it to be sustainable then? And well, that's also... Let's do 10 by 10. See how that works. See if that'll be a bit more. Do they... what? Well, that doesn't feel right. Is it because of how small the board is? I am curious. Because it looks like this one's thinning too. It is. Oh, no, it's not. Is it thinning? Right to the... Be a little. Okay. I think we're good. I'll upload all this code that I wrote with some comments and all of that. And hopefully, if I did mess something up, someone will be here to give me some tips. If not, well then, either way, I appreciate you stopping by and checking out this debacle. A little bit of a struggle at the very start, but we all figured it out at the end, so thank you so much. And of course, make sure to show support. This was a pretty awesome tutorial. In particular, the fact that really the only thing he directly gave you code for was the testing. I liked that. Now, I would like to learn to write my own testing, but either way, that was awesome. So much. Bye.